The UN Control Systems Master Plan, October 29, 2025. While you were going about your day, something the size of Manhattan reached the closest point to our sun, hidden, completely unobservable from Earth. The timing was perfect, too perfect. This is the exact moment a spacecraft would fire its engines to change course. Maximum efficiency, maximum energy gain. And 3 weeks earlier, the United Nations launched a global tracking campaign. Same day, SETI updated their contact protocols for the first time in 15 years. All eyes on 3i Atlas, all systems synchronized. The question isn't whether something is happening. The question is, what are they preparing for? If you're finding this fascinating, hit that like button and subscribe so you don't miss what comes next. And tell me in the comments where you're listening from, and whether you think this timing is coincidence or something more deliberate. Share this video and hit that hype button to help us grow. Thank you for being here. Let me walk you through something that should concern every single person paying attention to 3 Atlas. Not the object itself, though we'll get there. Not even the anomalies, the nickel emissions, the reverse tail. No, what should concern you is the infrastructure that appeared around this object before most people even knew it existed. An infrastructure designed to control information, to filter what reaches the public, to manage the narrative before there's anything to manage. September 30th, 2025, a white paper lands on the desk of the United Nations Office for Outer Space Affairs. The authors are Avi Loeb, Omal Dardi, and Gursian Tenbaum. The document advocates for coordinating global scientific research, maximizing observational coverage, ensuring optimal monitoring of interstellar objects like 3 Atlas, objects that could pose a threat to humanity if they happen to carry alien technology. Black swan events with small probabilities must be considered seriously if their implications are large. That's the language. That's the framing. 3 weeks later, October 21st, the International Asteroid Warning Network makes an announcement. They're initiating a campaign to monitor 3 through Atlas, a training exercise they call it, planetary defense. The dates are specific. November 27th, 2025 through January 27th, 2026. Right through the window when 3i Atlas emerges from behind the sun. When it becomes observable again, when any unusual activity, any trajectory changes, any deployed objects would become visible to Earth-based telescopes. Same day, October 21st, the Minor Planet Center issues an editorial notice. Comets present unique challenges for accurate astrometric measurements and orbit predictions. The notice is dry, technical, bureaucratic, but the timing, always the timing. And here's where it gets interesting. That same September, just before Lowe's white paper, SETI releases something they've been working on for 15 years, a revision of their post-detection protocols, the rules for what happens when we detect extraterrestrial intelligence. Who gets to communicate? Who gets to know? Who controls the message? The document is titled SETI Post-Detection Protocols Progress Towards a New Version. The lead author is Michael Michaud. Though the full team spans international boundaries, the framework effectively centralizes post-detection communication authority to a narrow circle of authorized scientists, government agencies, and international bodies. Read that again. A narrow circle. Authorized. The revision restricts who can speak, who can share, who can tell the world that we are not alone. Now on paper, these are separate projects. The SETI protocols have been in development for years. The IWN campaign is a legitimate planetary defense exercise. Lowe's white paper is academic advocacy. 3 unrelated initiatives from 3 separate organizations, all happening to converge in the same month around the same object. But let's think about what's actually being built here. SETI creates the reporting policy. They define what constitutes a detection, what evidence is sufficient, what channels must be used. IAWN runs the observational campaign. They coordinate the telescopes, the data collection, the measurements. They determine what gets flagged as anomalous. And DANUSA, the United Nations Office for Outer Space Affairs, sits at the apex of both structures. The only place where every national space agency already has a seat at the table. If you wanted to build a system to control information about an extraterrestrial object, this is exactly what you'd build, a pipeline. Data flows up from telescopes around the world. It gets filtered through IAWN's coordination network, processed according to SETI's protocols, reviewed by UNUSA's International Committee, and only then, only after passing through every layer of institutional review, does information reach the public. The beauty of it from a control perspective is that every step looks legitimate. Planetary defense is necessary. We need systems to track dangerous objects. Post-detection protocols are prudent. We need frameworks for first contact scenarios. International coordination is essential. Space is a global commons. No one can argue with any of that. But when you layer them together, when you synchronize their deployment around a specific object, you create something else entirely. You create a choke point, a single pipeline through which all information must flow. And here's the thing that keeps me up at night. This infrastructure appeared before 3.ia Atlas did anything unusual. The white paper was submitted when the object was still 4 astronomical units from the Sun, before the anti-tail reversed, before perihelion, before any of the timing coincidences that would later fuel speculation about artificial origin. They built the information control system in anticipation of needing it. Think about that for a moment. Either they saw something in the data that hasn't been made public, something that justified building this framework before the object became headline news, or they're running a drill, testing the system's capabilities using 3 Atlas as a convenient test case. Both possibilities are fascinating. Both raise questions that aren't being addressed in official channels. The ex-post that brought this to wide attention frames it perfectly. When I kept speaking about a blanketed silence, this is what I was talking about. If every anomaly has to be reported through the same UN-approved channel, then whoever runs that pipeline decides what's real, what's rumor, and what the public ever hears about. Call it planetary defense, and nobody bats an eyelid. You can build a global sensor grid, sync every major telescope, and monitor the skies 24/7 without ever saying the scary word UFO. And there's the language. Planetary defense money is automatic. No need for hearings, no headlines, the same infrastructure, safer branding. You want funding for a global telescope network to search for alien technology? Good luck with that congressional hearing. You want funding for planetary defense against potentially hazardous asteroids? Here's your budget. Here's your mandate. Here's your international coordination framework. Same hardware, same sensors, same data streams, different label. But the infrastructure does more than just observe. It tests us, the public. The so-called drills test something else. Us, the people, the same mugs funding it all. They test to see how fast a story spreads, who questions it, and which outlets copy-paste the official language. That's a stress test for information flow, not just asteroid tracking. When you know the flow of information, you also know how to muddy the waters. This is sophisticated. This is what information control looks like in the modern age. You don't suppress the story. You don't classify everything and hope it stays buried. That doesn't work anymore. Too many independent telescopes, too many amateur astronomers, too many people watching the sky. Instead, you build legitimate-looking institutions, you create official channels, you establish protocols and procedures and review boards, and then you make sure all the information flows through those channels. You become the authoritative source, the place journalists call for comment, the database where measurements get logged, the committee that determines what's anomalous and what's normal. And if something genuinely unusual happens, if 3 Atlas performs a maneuver or deploys objects or does anything that can't be explained as natural cometry activity, that information enters your pipeline. It gets reviewed by your committees. It gets contextualized according to your protocols. And by the time it reaches the public, it's been shaped, framed, managed, the rough edges smooth, the implications carefully worded, the narrative controlled. Unless, of course, something happens that's too obvious to contain, too visible, too many witnesses. That's the nightmare scenario for any information control system, the event that bypasses the pipeline entirely. And that's why the timing of this campaign matters so much. November 27th through January 27th, right when 3i Atlas emerges from solar conjunction, right when amateur astronomers can point their telescopes at it again, right when any post-Perryian activity would become visible. The IAWN campaign ensures that during this critical window, there's a coordinated global observation network already in place, already collecting data, already feeding information up through official channels. If something unusual appears in the sky, If backyard telescopes start picking up objects that weren't there before, the official network will see it too. Probably see it first, given their resources, and that means the official narrative gets established before the speculation takes over. It's actually brilliant in a Machiavellian sort of way. You're not suppressing information. You're not even really hiding anything. You're just making sure that when people look for authoritative information, when journalists need expert quotes, when the public wants to know what's really happening, they come to you. They trust your data. They accept your framing because you're the International Asteroid Warning Network. You're the United Nations Office for Outer Space Affairs. You're SETI, the organization that's been searching for extraterrestrial intelligence for decades. Who else would you trust? And maybe this is all exactly what it appears to be. Responsible scientific institutions doing responsible things. Building frameworks for scenarios that are unlikely but not impossible. Coordinating observations of a rare and interesting object. Testing their systems and procedures so they'll work properly if something genuinely dangerous appears. Maybe the timing is coincidence. Maybe the synchronization is just bureaucratic efficiency. Different organizations happening to act on the same problem at the same time. But there's another layer here that deserves attention, the psychological dimension. These drills, these campaigns, these protocols, they do something beyond their stated purpose. They normalize the idea of global coordination around potentially threatening objects from space. They establish in the public mind that this is something governments and international bodies take seriously, that there are systems in place, that someone is watching, that we're prepared. And if you're preparing the world for potential disclosure, for the possibility that we're not alone, that we're being visited, that there are technologies in our solar system we didn't build, this is how you do it. Not with a press conference, not with a dramatic announcement. You do it slowly, gradually. You'd build the infrastructure first, establish the institutions, create the protocols, run the drills, get people used to the idea that space agencies are tracking unusual objects, that international cooperation is necessary, that sometimes things happen that require careful management and coordination. Then, when the actual event occurs, when something undeniable appears, you're not starting from scratch. You're not trying to build trust and establish authority in the middle of a crisis. You've already done that work. The systems are in place. The public knows who to listen to. The narrative framework already exists. But they're not preparing us for disclosure. They're preparing to manage it. That's the key distinction. The information will come out one way or another. Too many eyes on the sky, too much data being collected by independent researchers, too many amateur astronomers with too much equipment. But managing how that information spreads, how it's interpreted, what conclusions people draw, that's achievable. That's what this infrastructure enables. Keep an eye on this situation because frankly it stinks. The original post ends with that assessment, and it's hard to disagree. Not because there's smoking gun evidence of conspiracy or cover-up, but because the pattern is there, the timing is there, the coordination is there, and the implications, if you follow them through to their logical conclusion, are extraordinary. This has nothing to do with 3i Atlas, the post concludes. It's about control and money. And maybe that's exactly right. Maybe this is just institutional power plays and budget justification, and bureaucratic empire building wrapped in the convenient packaging of an interstellar object. Or maybe, just maybe, they know something we don't. Maybe the data they're seeing, the measurements they're taking, the signals they're detecting justify exactly this level of coordination and preparation. Maybe they're building this infrastructure because they believe they're going to need it. We'll find out soon enough. November and December will tell us a lot. Not just about 3 Atlas itself, about what it does or doesn't do as it emerges from behind the sun, but about how the system operates, how information flows through these channels, how quickly official statements appear, how the narrative gets shaped. We're not just watching an object anymore. We're watching the machinery of information control in real time as it processes something genuinely unknown. NASA quote a selective shutdown. The Daily Mail caught them. October 1st, 2025. The United States government runs out of money again. 15,000 NASA employees receive furlough notices. Operations cease. Websites go dark. The space agency, America's crown jewel of scientific achievement, officially closes its doors. Except it doesn't. Not really. Not when it matters. 2 days later, 3IE Atlas makes its closest approach to Mars, 30 million kilometers. The Mars Reconnaissance Orbiter is perfectly positioned. The HIRE, capable of resolving objects down to 30 centimeters from Martian orbit, has a clear line of sight. This is the shot, the closest any human-made instrument will get to 3 Atlas during its entire passage through the inner solar system. The image that could reveal surface features, structure, composition, the data point that could answer whether we're looking at a comet or something else entirely. And NASA is closed. Or so they said. The Daily Mail of all outlets caught them in the contradiction. When the tabloid reached out for comment about 3 Atlas, NASA maintained that the entire space program is currently closed due to the ongoing government shutdown and did not comment further. Standard response, government boilerplate, we're sorry, we're furrowed, come back when Congress passes a budget. But here's what the Daily Mail noticed. Here's what they published, what they called out. What forced NASA into an uncomfortable position? If they're closed down, why are they putting out selective news like the quasi-mini moon announcement and sending out briefings? Seems a bit selective to me. Closed when it suits them. Let that sink in for a moment. During the same shutdown that prevented NASA from commenting on 3I Atlas, from releasing high-res imagery, from providing updates on the most significant interstellar visitor in years, they somehow found the resources to announce a mini-moon, a tiny asteroid in temporary orbit around Earth. Interesting, sure. Scientifically relevant, absolutely, but hardly urgent. Hardly the kind of thing that requires breaking the shutdown silence. The mini-moon announcement went out through official channels, included quotes from NASA scientists. It featured graphics and orbital diagrams. It was a full press package, professionally produced and distributed, all while the agency was supposedly closed. All while they couldn't spare the resources to discuss an interstellar object exhibiting 8 documented anomalies. This is what selective silence looks like. This is information control in its most obvious form. You don't shut down completely because that would be too suspicious. You don't release everything because then you lose control of the narrative. You pick and choose. You release information that's safe, that's mundane, that keeps the public engaged with space news without raising uncomfortable questions. And you sit on the information that's problematic, that's anomalous, that might generate speculation you're not prepared to address. The high-risk images exist. They have to. The Mars Reconnaissance Orbiter is automated. Its observation schedule is planned months in advance. The spacecraft doesn't care about government shutdowns. It executed its programmed observations of 3 Iatas on October 3rd. The data was collected. The images were downlinked to Earth. They're sitting on servers somewhere waiting for someone to process them, analyze them, decide what can be released and what should be held back. But NASA can't release them. Not yet. Because releasing them requires making decisions about what they show. If the images are boring, if they show exactly what you'd expect from a natural comet, releasing them is easy. Straightforward. Here's what we saw. Here's what it looks like. No surprises. But if the images show something unexpected, something that doesn't fit the comet narrative, then releasing them becomes complicated, requires consultation, requires coordination with other agencies, requires figuring out the messaging before the images hit the internet and people start making their own interpretations. The government shutdown provides perfect cover for this delay. Of course, we can't release the data. We're furrowed. Of course, processing is delayed, essential personnel only. Never mind that we're releasing other data. Never mind that selective operations continue. The shutdown is the excuse, the shield, the reason why the most important images of 3 Atlas aren't available for public analysis. And it's not just NASA. China's Tian-11 orbiter was also positioned to observe 3I Atlas during the Mars flyby. China has released over 14,000 images from that mission. They're aggressive about sharing their Mars data, about demonstrating their capabilities, about showing the world what they can do. And yet, 3 weeks after the flyby, not a single image of 3 Atlas from Tianwen-1, not even a press release acknowledging that they attempted the observation. The silence from Beijing is deafening and suspicious because this is exactly the kind of opportunity China usually jumps on. A chance to upstage NASA, a chance to be first with data, a chance to demonstrate that their space program is competitive, capable, worthy of respect. If 3 Atlas is just a comet, if the images show nothing unusual, China should have released them immediately. Look what we captured. Look what our instruments can do. Here's data NASA won't share because of their government dysfunction, but they didn't, which suggests one of 2 possibilities. Either China's observation failed, their instruments didn't capture useful data, in which case you'd expect them to say that to explain what went wrong, or they captured something that required consultation, coordination, perhaps even communication with other space agencies before deciding how to handle it. Reddit caught this pattern almost immediately. A thread titled "The Chinese Silence on 3I Atlas" is more concerning than NASA's started circulating within days of the flyby. The logic is sound. If this were an ordinary comet, China would have released pictures immediately to upstage NASA. The fact that they haven't, the fact that they're just as silent as the Americans suggest this isn't ordinary, suggests there's something in those images that requires careful handling. Meanwhile, the European Space Agency did release images, limited, carefully selected images from the Exxon Mars Trace Gas Orbiter. They show exactly what you'd expect. A fuzzy white dot, a faint coma of gas and dust, nothing remarkable, nothing that would generate headlines or fuel speculation. Safe images. The kind you release when you want to appear transparent without actually revealing anything significant. But here's the interesting part. ESA was explicit about the limitations of what they captured. The CAS could not distinguish the nucleus from the coma because 3 Atlas was too far away. Imaging this kilometer-wide nucleus would have been as impossible as seeing a mobile phone on the moon from Earth. That's the official statement. That's the technical limitation they're hiding behind. Except it's not really a limitation. It's a choice. CASIS is a surface imaging camera. It's designed to photograph Martian terrain from close range. Using it to observe a comet 30 million kilometers away is like using a microscope to look at distant mountains. Of course, you can't resolve fine details. Of course, the image is fuzzy, but ExoMars Trace Gas Orbiter has other instruments, spectrometers, infrared sensors, tools specifically designed to analyze distant objects to measure composition to detect anomalies. Why didn't ESA release spectroscopic data? Why didn't they discuss what their other instruments detected? Why focus exclusively on the camera that was least suited for this observation? Because the camera image is safe. It shows nothing controversial. It confirms the comet narrative without revealing anything that might contradict it. The other data, the spectroscopy, the infrared readings, those might tell a different story. So, you don't mention them, you don't discuss them, you release the fuzzy image and move on. This is the playbook. This is how information control works in the modern era. You appear to be transparent, you release data, you hold press conferences, you answer questions. But you control what gets released. You choose the safe revelations. You frame the narrative before anyone else can. And you use legitimate excuses, technical limitations, government shutdowns, processing delays to explain why the really interesting data isn't available yet. Aviv called this out directly. Who cares about the communication departments? We want to see the data from the scientists. That quote appeared in multiple interviews, and it cuts to the heart of the issue. This isn't about scientists being unable to work during the shutdown. This is about communication departments, public affairs offices, institutional review boards being unable to approve releases. The data exists. The scientists have seen it. But the machinery of institutional approval is frozen, and nothing gets out without that approval. Think about what that means. NASA scientists are sitting on the high-res images. They've processed them. They've analyzed them. They know what 3I Atlas looks like at close range, and they can't tell anyone. Not because the data is classified, but because the communication pipeline is shut down. Because the people who decide what can be shared aren't working. Because the system requires multiple layers of approval before anything reaches the public, and those layers aren't functioning. This is information control through bureaucracy, through process, through the normal functioning of institutional machinery. You don't need conspiracy. You don't need cover-up. You just need the standard review process to be slow enough, cumbersome enough that by the time information gets released, it's old news. The moment is past, the narrative is already established, and whatever the data might have revealed is buried under layers of context and interpretation and official framing. But sometimes the timing is too obvious to ignore. Sometimes the contradiction is too glaring. And that's what the Daily Mail caught. That's what forced NASA into an uncomfortable position. You can't claim to be completely shut down while simultaneously releasing press packages about mini-moons. You can't have it both ways. Either you're closed, in which case nothing gets released, or you're selectively operational, in which case people will wonder why some information flows and other information doesn't. NASA chose selective operation. They chose to maintain some public presence to keep the space news cycle moving, to prevent the complete information blackout that would itself generate speculation. But in doing so, they revealed the game. They showed that information release is a choice, that some stories get told while others get delayed, that priorities are set by criteria we're not privy to. And what does it say that 3 Atlas fell on the wrong side of that priority list? What does it say that during the most critical observational window of this object's passage through our solar system, during the closest approach to any human spacecraft, during the moment when we could finally see what this thing actually looks like, NASA chose silence, chose to hide behind the shutdown, chose to let the opportunity pass without public acknowledgement? It says they're not ready to show us what they saw. It says the images require more analysis, more consultation, more time to figure out the messaging. It says that whatever HiRISE captured doesn't fit neatly into the natural comet explanation that's been the official position since day one. Because if it did fit, if the images were boring and confirmatory and exactly what you'd expect, there's no reason to delay, no reason to wait, no reason to let speculation build while you sit on data that could settle the question. The longer the delay continues, the more suspicious it looks. Every day without release is another day that suggests the images are problematic, that they show something unexpected, that they require careful handling before they can be shared with the public that's increasingly skeptical of official explanations. And this is just the beginning. 3 Atlas is about to emerge from behind the sun. Amateur astronomers will get their telescopes on it again. Independent observations will flood social media. If anything unusual appears, if the object's behavior post-perihelion doesn't match predictions, it won't matter what NASA says or doesn't say. The evidence will be out there. The images will circulate. The speculation will intensify. Unless, of course, the official channels move first. Unless the IWN campaign captures that data. Unless the Coordinated Observation Network sees it before the amateurs do. Unless the information flows through the pipeline that was so carefully constructed in September and October, then the narrative gets established by authoritative sources, then the framing comes from institutions people trust. Then the speculation gets managed before it spirals out of control. That's what's at stake here. That's why the shutdown timing matters. That's why the selective silence is so revealing. They're buying time, preparing the ground, making sure that when information does flow, it flows through channels they control. The ESA whistleblower claim. October 21, 2025, late evening, Central European Time. A post appears on social media that changes everything. The author identifies themselves as a space debris engineer, analyst at the European Space Agency. The language is technical, the details are specific, the claims are extraordinary. In mid-September, Fermi GST has detected a stable signature on the object, which is not attributable to any other space source. In other words, the object emits constant engine-like sound. Read that again. Engine-like sound. Not a burst, not a pulse, not the kind of emission you'd expect from natural processes like outgassing or particle collisions. Constant, stable, the signature of something powered, something active, something operating. The post goes viral within hours. Screenshots circulate. Analysis threads spawn across multiple platforms, and the questions start immediately. Is this legitimate? Is this person really an ESA employee? Is the Fermi data real? And if any of this is true, why is it coming from an anonymous social media post instead of official channels? Let's break down what's being claimed here. The Fermi Gamma Ray Space Telescope is a real instrument. It's been operational since 2008, scanning the entire sky every 3 hours, mapping sources of high-energy radiation, gamma rays, X-rays, the most energetic light in the universe. Fermi detects pulsars, black holes, supernova, active galactic nuclei, cosmic violence, extreme physics, and apparently, according to this whistleblower, something coming from 3 Atlas. But here's the thing about Fermi data. It's public. Every observation gets archived. Every detection gets cataloged. If FMI really picked up an anomalous signal from 3 Atlas in mid-September, that data exists in accessible databases. Researchers can verify it. Amateur astronomers can analyze it. The claim is falsifiable, which makes it either incredibly bold or incredibly stupid, depending on whether it's true. The whistleblower continues. Something big is about to happen. In December, many home-based observers will see it all. That's the prediction. That's the timeline. Not vague someday speculation. Specific December when 3I Atlas emerges from behind the sun, when amateur telescopes can observe it again. When whatever's been happening during the hidden perihelion passage becomes visible. The Post alleges a massive cover-up between ESA and NASA, top-secret data deliberately hidden from the public and even from fellow space agency analysts. That last part is crucial even from fellow analysts. The implication is that information is being compartmentalized within the agencies themselves, that only certain people, certain teams, certain levels of clearance have access to the full picture. Everyone else, including lower-level analysts, is working with incomplete data. This is how real information security works. Not everyone in the building gets to see everything. Not every scientist working on a project has access to all the data. You segment, you compartmentalize, you ensure that no single person, no single team can see the whole picture unless they're specifically authorized. It's standard practice for sensitive programs. And if you're dealing with something that could cause public panic, something that challenges fundamental assumptions about what's possible, this is exactly how you'd handle it. But why would an ESA engineer risk their career, potentially their freedom, to post this information anonymously on social media? What's the motivation? Conscience? Fear? Belief that the public deserves to know, or something else entirely? There's a theory circulating that this isn't really a whistleblower, that this is a limited hangout, a controlled leak, information released intentionally through unofficial channels to gauge public reaction, to test the waters, to see how people respond to the idea that 3 Atlas might be artificial before making any official statements. Intelligence agencies do this all the time. Float a story, see how it spreads, measure the response, adjust your strategy accordingly. If that's what's happening here, it's sophisticated. The details are specific enough to seem credible, but vague enough to avoid revealing classified information. The timeline is near enough to maintain urgency, but far enough to allow for adjustment if the prediction doesn't pan out. And the framing, a concerned insider breaking ranks to warn the public, is emotionally compelling. It bypasses skepticism. It makes people want to believe. But let's assume for a moment that this is legitimate, that there really is an ESA analyst who's seen data that convinced them something extraordinary is happening. What would that data look like? What could Phi have detected that would warrant the term engine-like sound? FMI doesn't actually detect sound. Space is a vacuum. There's no medium for sound waves to propagate. What Fermi detects is electromagnetic radiation in the gamma-ray spectrum, high-energy photons. But certain patterns of emission can be described as acoustic, regular, rhythmic, pulsed at consistent intervals. Pulsars, for instance, are often described as cosmic lighthouses. The radiation sweeps across space like a beam, regular as clockwork. That's a kind of signal you could metaphorically call sound. But pulsars are natural, rotating neutron stars with intense magnetic fields. Nothing artificial about them. So, what would an artificial signal look like? What would make an analyst describe it as engine-like? Stability would be key. Natural sources vary, they flicker, they fluctuate, they respond to environmental conditions. But an engineered signal would be consistent, locked to a frequency, maintained at constant power, no drift, no variation. The kind of signal that screams artificial the moment you see it in the data. And if 3i Atlas is emitting such a signal, if Fermi really detected it in mid-September, that has profound implications because mid-September was before perihelion, before the closest approach to the Sun, before any potential Earth maneuver. The object was already active, already powered, already operating whatever systems might be generating that signal. This contradicts one of the key predictions of the artificial hypothesis. The expectation was that if 3i Atlas is a spacecraft, it would wait until perihelion to perform major maneuvers, maximum efficiency, optimal energy transfer. But if it's already radiating at gamma-ray energies a month before perihelion, that suggests active systems throughout its approach, continuous operation, not a dormant probe waiting for the right moment, but an active mission with ongoing power requirements. What would require that much power? What systems would generate gamma-ray emissions? There are a few possibilities, none of them comfortable. If you're accelerating matter to high velocities, if you're running a fusion reactor, if you're manipulating magnetic fields at enormous scales, you'd produce gamma rays as a byproduct. These are all technologies we can imagine but not yet achieve. Technologies that would indicate capabilities far beyond our current engineering. Or alternatively, what we're interpreting as artificial could be natural but exotic. Some new kind of cometry process we've never observed before. Some interaction between the object and the solar wind that generates high-energy radiation. Some phenomenon that mimics technological signatures without actually being technological. This is always the counter-argument. This is always the more likely explanation from a Bayesian perspective. We've seen thousands of comets. We've never seen alien spacecraft. Prior probabilities matter. But the whistleblower isn't claiming gamma rays. They're claiming a stable signature not attributable to any other space source. That suggests comparison analysis. Someone went through the catalog of known sources, known phenomena, known natural processes, and found that none of them match what Fermi detected from 3i Atlas. That's a strong claim. That's not just seeing something unusual. That's ruling out alternatives. That's concluding, at least provisionally, that this is something new. The December prediction adds another layer. Many home-based observers will see it all. What does that mean? See what exactly? If there's a gamma-ray signal, amateur telescopes can't detect that. You need space-based instruments, specialized detectors. So what will be visible to ground-based observers that isn't visible? Now, one possibility is trajectory deviation. If 3 Atlas performed a maneuver at perihelion, if it changed velocity or direction in a way that can't be explained by gravitational forces, that would become apparent as the object emerges from behind the Sun. Astronomers would plot its position, compare it to predicted trajectories, and immediately notice the discrepancy. That's something home-based observers could detect and verify independently. Another possibility is debris. If 3i Atlas released smaller objects, if it deployed probes or shed components, those would begin to separate from the main body as they follow slightly different trajectories. Over weeks and months, the separation would become visible. Amateur telescopes would pick up multiple objects where there should be only one. That's unambiguous. That's impossible to explain as natural. A third possibility is the object itself changes appearance. If an active system was radiating, if engines were firing, if there was propulsion visible in optical wavelengths, amateur observers would see a comet that doesn't look like a comet, that behaves unlike any comet, that shows clear signs of artificial activity. Any of these would be extraordinary. Any would force a complete reassessment of what 3i is, and any would be visible to the distributed network of amateur astronomers who've been following this object since July. You can't contain that. You can't manage that narrative. Once hundreds of independent observers are posting images and data, once the evidence is coming from sources outside institutional control, the game changes. That's why the December timeline matters. That's what the whistleblower might be hinting at. Not that ESA or NASA will release information, but that the information will force itself into public view regardless of what the agencies want. That the object's behavior post-perihelion will be so obviously anomalous that no amount of official explanation can maintain the natural comet narrative. But we have to sit with the uncertainty. We have to acknowledge that this could all be false, a hoax, misinformation, someone with technical knowledge crafting a believable story to generate attention. It happens. It happens often, and the pattern is familiar. Anonymous insider dramatic claims near future prediction. Just far enough out that by the time it doesn't happen, everyone's moved on to the next thing. The responsible position is skepticism. Healthy doubt. Wait for confirmation. Wait for the data. Wait for December and see if the prediction pans out. Don't get swept up in speculation based on an unverified social media post, no matter how technically detailed it sounds. And yet there's something about the specificity that's compelling. The Fermi reference, the mid-September timeline, the December prediction. These are all falsifiable claims. If someone's making this up, they chose checkable details. They gave the world specific things to verify or debunk. That's either very confident or very reckless. The space community is divided. Some researchers are digging through Fermi archives, looking for any anomalous detections in the 3 Atlas region of sky during September. Others are dismissing the whole thing as obvious fabrication, and most are waiting, watching, wondering if December will bring vindication or embarrassment to whoever posted that claim. What we do know is this: the post went viral for a reason. It tapped into existing suspicion, existing doubt about official explanations, existing frustration with the lack of transparency around 3I Atlas. People want to believe there's more to this story. They want to believe that someone inside the system is brave enough to speak truth to power, to break ranks, to warn us about what's really happening. Whether that belief is justified, whether this anonymous post is genuine insider information or sophisticated misinformation, we won't know until December, until 3I Atlas emerges from behind the sun. Until we can point our telescopes at it again and see for ourselves what, if anything, has changed. The waiting is the hardest part, the not knowing, the possibility that hangs in the air like charged particles before a storm. Something big is about to happen or nothing will happen, and we'll all feel a bit foolish for hoping that maybe, just maybe, this time it was real. The perihelion window, October 29, 2025. There are moments in astronautics that define what's possible. Moments when physics aligns in ways that transform ordinary trajectories into extraordinary opportunities. October the 29th, 2025 was one of those moments. At exactly 203 million kilometers from the Sun, 3 Atlas reached perihelion, its closest approach, its maximum velocity. The point where if you wanted to change course efficiently, if you wanted to maximize energy transfer, if you wanted to execute a maneuver with minimum fuel expenditure, you would act. This is called the Oerth effect. Named after Hermann Oberth, a pioneer of rocketry who understood that the best time to burn your engines is when you're already moving fast, when you're deep in a gravity well, when your orbital velocity is at maximum. The physics is counterintuitive. You'd think firing engines when you're moving slowly would be more efficient, more controllable. But that's not how orbital mechanics works. When you're at perihelion moving at peak velocity, every meter PS of delta V you add translates into maximum kinetic energy change. The math is brutal in its clarity. The energy gain scales with your velocity at the moment of thrust. Double your speed, double the energy transfer, triple your speed, triple the gain. At perihelion, 3I Atlas was moving at 68 km/s. Firing engines at that velocity means every gram of propellant produces maximum possible effect. And this optimal window occurred while 3I Atlas was hidden, completely unobservable from Earth. Solar conjunction had placed it directly behind the Sun 8 days earlier. No ground-based telescope could see it. No Earth-orbiting spacecraft had line of sight for those 8 days. From conjunction on October 21st through perihelion on October 29th, 3I Atlas operated in perfect privacy. Whatever happened during that window happened without witnesses. Was this a coincidence? Avabe has asked that question repeatedly in papers, in interviews, in blog posts that dissect the statistical improbability of this timing. The object's trajectory brings it within tens of millions of kilometers of Mars, of Venus, and Jupiter. That's unusual. The probability is 0.05%, 5 chances in 10,000 already unlikely. But to also have perihelion occur during solar conjunction when Earth-based observation is impossible, that adds another layer of improbability. If you were designing a mission, if you were planning a trajectory for an interstellar probe entering a foreign solar system, if you wanted to perform a major maneuver without being observed by the inhabitants of the third planet, this is exactly when you do it, hidden behind their star, moving at maximum velocity, positioned for optimal gravitational assist. The timing is too perfect to be comfortable. Lois assigned 3i Atlas a rank of 4 out of 10 on his scale of possible technological origin. That scale is quantified, specific, based on probability calculations for each observed anomaly. 4 out of 10 doesn't sound high, it's less than half, but in context, it's extraordinary. Most objects score 0. Natural comets, asteroids, everything we've seen before. They accumulate no points on this scale. They're clearly natural. Obviously, gravitationally bound debris from planetary formation. 3 Atlas accumulated 4 points through 8 distinct anomalies, 8 different ways it deviates from what we'd expect from a random interstellar rock. The ecliptic alignment, the anti-tail that pointed sunward, the convenient arrival timing that allows close planetary encounters, the extreme nickel-to-iron ratio resembling industrial alloys, the nickel-to-cyanide ratio orders of magnitude higher than any known comet, the unusually low water content, the unprecedented negative polarization, and the trajectory origin within 9 degrees of the WOW signal direction. Each anomaly individually can be explained. Unlikely, but possible. Natural processes can produce strange results. Cometary chemistry is diverse. We've only observed 3 interstellar objects. Our sample size is pathetic. Maybe 3i Atlas represents normal interstellar diversity, and our expectations are just poorly calibrated. But 8 anomalies together, 8 separate ways this object deviates from normal, 8 different improbabilities compounding. That's when statisticians start getting uncomfortable. That's when the hypothesis that looked ridiculous initially starts seeming less absurd, not proven, not even likely, but possible enough to warrant serious consideration. And perihelion was the test, the moment of truth. If 3i Atlas is artificial, if it's a probe or spacecraft or whatever terminology you prefer for technology not built by humans, perihelion was when it would act, when it would take advantage of the Earth effect. When it would perform the maneuver it traveled all this way to execute. What would that maneuver look like? Several possibilities exist, each with different implications. The most dramatic would be a reverse Earth, fire engines opposite to your direction of motion, slow down, shed velocity. Instead of passing through the solar system on a hyperbolic trajectory, capture into a bound orbit, stay. Become a permanent resident of this star system instead of a temporary visitor. The delta V required for this is substantial. 3i Atlas was moving at 44 km/h when it entered the inner solar system. To slow down enough to be captured by the sun's gravity, you'd need to shed a significant fraction of that velocity, tens of km/h. That requires either a lot of fuel or a very efficient engine or both. But if you're going to make that maneuver, perihelion is where you do it. Maximum efficiency, minimum fuel expenditure. And if you time it during solar conjunction, you do it without witnesses. By the time Earth-based observers can see you again, the maneuver is complete. Your new orbit is established. You're already moving on your post-capture trajectory. A second possibility is trajectory adjustment, not a full capture, but a course correction. Bend your path slightly, aim for a specific target, set up a future encounter with a planet or moon. This requires much less delta V, much more subtle, harder to detect unless you're measuring very precisely, but it would show up eventually. As the object emerges from solar conjunction, as astronomers plot its updated trajectory, they'd notice it's not quite where predictions said it should be. The deviation would be small but measurable and unexplainable by gravitational forces alone. A third possibility is deployment. Release smaller objects, mini probes, daughter craft, whatever you want to call them. At perihelion, at maximum velocity, objects released from 3i Atlas would gain maximum separation over time. After weeks and months, they'd spread out along slightly different trajectories. Some aimed at inner planets, some at outer planets, some maybe just mapping the solar system in detail before the mothership exits. This is actually the scenario that worries some researchers most. Not a single anomalous object to track and study, but multiple objects distributed following different paths. Some may be small enough to avoid detection for extended periods, a fleet rather than an individual visitor. That changes the problem entirely. That makes containment impossible. That means even if official channels can control information about 3i Atlas itself, they can't control information about objects that separate and go their own ways. Lowe has been explicit about this possibility. If 3i Atlas is a massive mothership, it will likely continue along its original gravitational path and ultimately exit the solar system. The Oberth maneuver might apply to the mini-probes it releases at perihelion towards solar system planets. That's the educated guess. That's the scenario consistent with engineering logic. Don't slow down the big valuable mothership. Let it pass through, collect data, and continue on. But release expendable probes to gather detailed information from specific targets. The tidal force from the sun would separate objects released at perihelion. Different masses, different sizes, different surface areas relative to mass. They'd respond differently to solar radiation pressure and gravitational gradients. Over months, the separation would become dramatic. Objects initially meters apart would end up millions of kilometers apart. That natural dispersal provides coverage, redundancy, multiple data gathering platforms distributed across the inner solar system. And here's what makes this scenario particularly challenging to confirm or deny. Small objects are hard to detect. Our asteroid surveys are optimized for finding things big enough to threaten Earth, things hundreds of meters across or larger. But an object the size of a car or a bus or even a small building that's much harder to spot, especially if it's not reflecting much light, especially if it's designed not to be conspicuous. We wouldn't necessarily know if 3 Atlas released something at perihelion. Not immediately, not unless we were watching with the right instruments at the right time. And we weren't watching. Solar conjunction prevented that. By design or by coincidence, the most critical moment of 3 Atlas's passage occurred when we couldn't observe it. Now we wait. Now we watch as the object emerges from behind the sun in November and December, as amateur and professional telescopes reacquire it, as precise position measurements resume. We'll be able to reconstruct what happened during the hidden window. Trajectory analysis will reveal whether any maneuvers occurred. Multiple object tracking will determine whether anything separated from the main body. Spectroscopy will show whether the object's activity changed in ways inconsistent with natural outcasting. The data will tell the story eventually. Maybe not the whole story, but enough to answer some questions. Did 3 Atlas follow purely gravitational dynamics through perihelion, or did something else influence its motion? That's answerable. That's measurable. That's the kind of question science is built to address. But there's a shadow question beneath the measurable one. A question that can't be answered by trajectory data or spectroscopic analysis. If 3 Atlas did maneuver, if it did deploy objects, if it did take advantage of the Oerth effect during its hidden passage, who is it hiding from? Natural processes don't care about observers. Comets don't wait for solar conjunction to outgas. Asteroids don't time their orbits for privacy. Only something aware of being watched, only something concerned with observation, only something with intent and planning and purpose would care about performing critical operations during the one window when Earth-based detection is impossible. That's the implication. That's what makes the timing so uncomfortable. Not just that it's optimal from an engineering perspective, but that it's optimal from a strategic perspective, that it shows evidence of planning around the capabilities and limitations of Earth-based observation. 33 GW of power hit the surface of 3i Atlas at perihelion. The solar illumination at that distance, focused on an object 5 kilometers across, delivers more energy than 30 nuclear reactors. That's available power. That's what a natural comet uses to sublimate ice to drive outgassing to create the coma and tail we observe. But it's also what a technological object could harvest, what it could use to run systems, to charge batteries, to power whatever operations it needed to perform. We think of spacecraft as being power limited. Our probes run on tiny nuclear batteries or modest solar panels. They ration every watt. They carefully budget their energy expenditure. But an object at parhelion, an object deliberately designed to perform operations during closest solar approach, that object has power. Abundant power. More than enough for any reasonable engineering task. This is speculation piled on speculation. This is taking thin evidence and building elaborate scenarios. But that's what happens when you have a mystery. When you have an object that doesn't quite fit, when you have timing that's too convenient to dismiss but too uncertain to confirm. You imagine possibilities. You sketch scenarios. You try to map the space of what could be true, even if you can't determine what is true. October 29th came and went. 3 Atlas reached perihelion and continued on its way. From our perspective, from Earth's vantage, nothing dramatic happened. No explosions, no visible maneuvers, no obvious signs of artificial activity. The object remained hidden behind the sun, and we remained ignorant of what, if anything, transpired during those critical hours. But absence of evidence is not evidence of absence. We didn't see nothing happen. We saw nothing. Period. We were blind, and in that blindness, in that gap in observation possibilities, multiplied questions, accumulated doubt flourished. The truth is somewhere in the data we don't have yet. In the higher images, still unreleased in the trajectory measurements that will be made in November and December, in the observations that JUICE will capture, in the analysis that's happening behind closed doors. In space agencies around the world, the truth is being determined right now by instruments and databases and scientists working through the evidence. We're just waiting for them to tell us what they found, or what they're willing to say they found. Those might not be the same thing. The anti-tail reversal mystery. Something changed between July and September, something visible, something documented. The tail of 3 Atlas, that plume of gas and dust that had been pointing toward the sun in reverse direction. What was an anti-tail became a normal tail. What was anomalous became conventional, and the question everyone's asking is why. The Nordic Optical Telescope in the Canary Islands captured the transition. A 2.5-meter diameter mirror, a patient observation campaign spanning months, and a clear photographic record of 3 Atlas transforming. The images are unambiguous. In July and August, the brightest emission from the object formed a fan-shaped structure pointing sunward. By September, that structure had reoriented. The dust and gas was streaming away from the sun exactly as you'd expect from normal cometry activity. David Jewett and Jane Lu Yu, 2 of the most respected comet researchers in the field, published the observations. Their analysis is careful, technical. They note that the mass loss rate from 3 Atlas scales roughly with solar radiation flux. As the object gets closer to the sun, as it receives more energy, it sheds more material. That's standard cometry behavior. The dependence is consistent with carbon dioxide being the main driver of activity. That's what spectroscopy told us earlier. CO2 sublimating from the surface, carrying dust particles along, creating the visible coma. Nothing unusual about that, nothing that would raise eyebrows or generate headlines, except for the anti-tail, except for the fact that for 2 months the brightest emission was pointing the wrong direction against the solar wind, against radiation pressure, against everything we know about how tails form. Anti-tails are not unprecedented. We've seen them before on solar system comets, but they are almost always optical illusions, geometric artifacts. The tail is actually pointing away from the sun like it should, but Earth's viewing angle makes it appear to point sunward. Change your perspective, wait a few days for orbital geometry to shift, and the illusion resolves. The tail is where it's supposed to be. But 3 Atlas was different. Multiple observations from different angles confirmed the anti-tail was real, not a perspective effect, not an illusion. The dust was genuinely moving sunward against the forces that should push it away. That requires explanation. That means something about this object's environment or composition or behavior doesn't fit the standard model. Enter Loeb and Eric Quito with a detailed theoretical model. They posted it online, walked through the physics, explained the transition from anti-tail to normal tail. Their model focuses on ice sublimation rates. As 3 Atlas approaches the sun, temperature increases exponentially. That's not linear. That's not gradual. Small changes in distance produce large changes in temperature, which produce even larger changes in sublimation rate. At 3 to 4 astronomical units from the sun, water ice fragments dominate the scattering signal. They're big enough, numerous enough, reflective enough to be the main thing we see, but they have short resonance times. They don't last long in the outflow. They sublimate or fragment quickly. As the object gets closer, as temperature rises, the sublimation rate increases sharply. The resonance time decreases. The ice fragments spend less time visible before they disintegrate. Meanwhile, refractory dust particles, the rocky stuff that doesn't sublimate easily, those persist. They survive longer in the outflow. They accumulate, and at closer distances, they become the dominant scatterers. They're what we see when we look at the object, no longer ice-dominated. Now, dust-dominated, and dust responds to radiation pressure differently than ice. Dust forms normal tails. Dust streams away from the sun. The model explains the transition. It's elegant physics. It matches the observed timeline. It provides a natural explanation for what seemed anomalous. Problem solved, right? The anti-tail was just an unusual but explicable phase in 3 Atlas's evolution as it approached the sun. Nothing artificial about it, nothing that requires invoking technology or intentionality. But then Adam Hibbert, a colleague of Lowe's, offers an alternative interpretation. If 3 Atlas is an engineered spacecraft attempting to slow down, this transition from anti-tail to tail near perihelion would represent exactly what you'd expect from a shift between braking thrust and forward propulsion. Read that twice. Let it sink in. A shift between braking and acceleration, a change in engine configuration, a spacecraft adjusting its maneuver based on current velocity and desired final state. This is what makes 3I Atlas so frustrating to analyze. Every observation has 2 interpretations. Every data point fits both the natural explanation and the artificial hypothesis. The anti-tail could be unusual ice sublimation dynamics, or it could be exhaust from a braking burn. The transition to a normal tail could be changing dust composition, or it could be a switch from deceleration to acceleration mode. Both explanations are internally consistent. Both match the observations. Neither can be definitively ruled out without more information. This is called degeneracy in science. Multiple models fitting the same data. It happens all the time. Usually you resolve it by gathering more data, by making more precise measurements, by finding observations that distinguish between the competing explanations. But with 3 Atlas, we're limited. We get the observations we can make from Earth's vantage with the instruments we have during the windows when the object is visible. We don't get to design the perfect experiment. We don't get to control variables or isolate factors. So we're stuck with ambiguity, stuck with 2 narratives that both seem plausible. And the choice between them comes down to prior probabilities. How likely is it that we're seeing a natural comet with unusual but explicable properties versus how likely is it that we're seeing alien technology? Most scientists would say the former is vastly more probable. We've seen thousands of comets. We've never seen alien spacecraft. The natural explanation should always be preferred unless evidence definitively rules it out. But Lowe and others argue that we shouldn't be so confident in our prior. We've only observed 3 interstellar objects. 3. That's not a sample size that tells us anything about the diversity of what's out there. Maybe interstellar comets are wildly variable. Maybe extreme chemistry is common. Maybe what seems anomalous to us is actually normal for objects that formed in different stellar environments. Or maybe, just maybe, some fraction of interstellar objects aren't natural at all. Maybe probe missions between stars are common. Maybe we're seeing exactly what we should expect if technological civilizations explore their galactic neighborhood. We can't resolve this through pure reasoning. We need data. And fortunately, there's a specific measurement that could distinguish between the natural and artificial explanations. Mass loss. If 3 Atlas is a comet shedding dust and gas naturally, there should be a clear relationship between the amount of material lost and the observed brightness of the tail. More mass lost equals more visible particles equals brighter tail. That relationship is quantifiable, testable. The observations show that 3I Atlas lost about 2 million tons of material during July through October. That sounds like a lot, 2 million tons, but compared to the total mass of the object, it's negligible. The object is estimated to have a mass larger than 33 billion tons. Losing 2 million tons is 0.2 of the total, basically nothing. A rounding error. To put that in perspective, the entire plume required ablating a surface layer with an average thickness of 4 centimeters. 4 centimeters out of an object 5 kilometers across. That's the ratio between the length of the palm of your hand and the length of Manhattan Island. Lowe's analogy is perfect. We've seen the surface, we've seen the skin, and we have no idea what's underneath. You can't infer the interior composition of an object from 4 centimeters of ablated surface material. You can't determine whether it's ice or rock or metal or something else entirely. The outgassing could be coming from surface volatiles that have nothing to do with the bulk composition. The tail could be telling us about what's been deposited on the outside, not what's built on the inside. This is crucial. This is why the mass loss data doesn't settle the question. Yes, we observed cometry activity. Yes, the object is shedding gas and dust in ways consistent with a natural comet. But that surface activity doesn't prove the entire object is natural. It just proves the surface behaves like we'd expect if it's coated with ices and dust. What's underneath that coating? What comprises the bulk of the object's mass? That remains unknown. A technological object passing through the solar system would accumulate surface ices. Millions of years in interstellar space, drifting through molecular clouds, encountering trace gases and particles, you'd build up a coating. And when that object approaches a star, when solar heating kicks in, that coating would sublimate. It would look exactly like a comet. The exterior would behave naturally, even if the interior is artificial. This is the stealth problem. This is why distinguishing between natural and artificial objects might be harder than we assume. If an advanced civilization wanted to send probes to other star systems without being immediately obvious, coating them in icy material would be smart engineering. Natural camouflage. You'd look like every other interstellar iceberg until someone examined you closely enough to notice the anomalies. And 3 Atlas has the anomalies, 8 of them. Statistical outliers that individually are unlikely but not impossible, but collectively paint a picture that's harder to dismiss. The anti-tail was one of those anomalies. Not the strongest evidence, not the smoking gun, but another data point that doesn't quite fit. Another reason to look more carefully. Another hint that maybe possibly this object deserves more scrutiny than we'd give a typical comet. The reversal from anti-tail to normal tail doesn't change that assessment. It actually makes it more interesting because now we have documented behavioral change. We have an object that was doing one thing and then switched to doing something else. And the timing of that switch, right as it approached perihelion, right as it entered the optimal window for maneuvers, the timing raises questions. Did the object change? Because physical conditions changed. Temperature, increased sublimation, dynamics shifted, different materials became dominant in the outflow. That's the natural explanation. That's what Loeb and Keto's model describes. And it's probably right. Probably, or did the object change? Because its operational mode changed because it completed a braking phase and transitioned to a different configuration. Because whatever mission profile it was executing required different thrust profiles at different points in its trajectory. That's Hibbett speculation, and it's almost certainly wrong. Almost. The gap between probably and almost certainly is where the interesting questions live. That's where uncertainty breeds speculation. That's where we're forced to admit we don't know enough to be absolutely sure. And being forced to admit uncertainty is uncomfortable for scientists who are used to confidently explaining phenomena, who are used to having models that work, who are used to natural explanations being sufficient. 3 Atlas challenges that confidence, not definitively. Not with unambiguous evidence, but persistently, repeatedly, with one anomaly after another, with timing that's too convenient, with behavior that's too unusual, with observations that keep generating alternative interpretations even when natural explanations exist. The Nordic optical telescope images are beautiful, scientifically valuable. They document a transition that tells us something important about how interstellar comets evolve as they approach a star. Dwight and Liu's analysis is solid. Low and Keto's model is sophisticated. This is good science. This is the process working as it should. Observation, analysis, theoretical explanation, published results, exactly what we want to see. But underneath all of that, underneath the careful measurements and mathematical models, there's a current of unease, a sense that maybe we're explaining what we can measure while missing what really matters, that maybe the surface phenomena we observe are distracting us from deeper questions about what this object is. 4. That's all we've seen. That's all the material that ablated during 3 months of observation, the palm of your hand versus Manhattan Island. And we're making judgments about the entire object based on that tiny sample, based on the outermost layer, based on what the sun's heat stripped away during its approach. What's underneath remains hidden. What comprises the bulk of the mass remains unknown. What's happening inside, if anything is happening inside, remains speculation. We've measured the skin. We haven't examined the body. And until we do, until we have better data, deeper measurements, closer observations, the question remains open. Is 3 Atlas a comet, or is it something pretending to be a comet? The tail reversal doesn't answer that. It just adds another piece to a puzzle that keeps getting more complex the more we look at it. Europa Clipper and Hera I on tail passage. Sometimes opportunity arrives by accident. Sometimes trajectories align in ways nobody planned, but everyone can exploit. Between October 30th and November 6th, 2 spacecraft on completely unrelated missions found themselves positioned to fly through the ion tail of 3I Atlas. Not by design, not because anyone calculated these intercepts when the missions were planned years ago, but because orbital mechanics occasionally produces serendipity. Europa Clipper launched toward Jupiter just months ago. Its mission is to study the icy moons to search for conditions that might support life beneath frozen surfaces. Ha is headed toward a binary asteroid system, part of humanity's first planetary defense test. Neither mission cares about 3 Atlas. Neither was designed to study comets, but both happen to be in the right place at the right time to sample material streaming away from the most mysterious object to visit our solar system in years. The physics of cometary ion tails is straightforward. Solar wind, that constant stream of charged particles flowing outward from the sun, hits the coma around the comet. Molecules get ionized, electrons are stripped away. What remains are charged atoms, ions that respond to magnetic fields. The solar wind carries its own magnetic field, and that field drags the ions along, not straight back from the comet, not in a simple line, but curved, following the complex topology of the interplanetary magnetic field. Predicting exactly where those ions end up is complicated. You need to know the solar wind speed, the magnetic field strength, the rate at which the comet is producing ions. All of these vary. All of these depend on conditions that change day by day, hour by hour. But you can make estimates. You can calculate probable paths. You can determine whether spacecraft along certain trajectories might intercept the tail. 2 researchers, Grant and Jones, did exactly that calculation for 3 Atlas. They mapped the expected iron tail trajectory. They checked the positions of spacecraft in the inner solar system, and they found that Europa Clipper and Hera would both pass through regions where ions from 3 Atlas should be present. Not through the central axis, not through the densest part of the tail, but close enough within 8 million kilometers of the central trajectory for both spacecraft. 8 million kilometers sounds far. It is far, but iron tails from active comets spread over enormous volumes, millions of kilometers wide, tens of millions of kilometers long. The ions are sparse, widely scattered, but detectable if you have the right instruments, and Europa Clipper does. It has a plasma instrument designed to measure charged particles around Jupiter's moons. It has a magnetometer to detect magnetic field variations. Both instruments can detect the signature of cometary ions if the spacecraft encounters them. High-A, unfortunately, doesn't have the right equipment. Its instruments are optimized for studying asteroid surfaces and composition. It can't detect ions. It can't measure magnetic fields with the precision needed. So even if Hera flies through the densest part of 3 Atlas's tail, it won't know. It won't gather usable data. The opportunity will pass unnoticed by the spacecraft's sensors. But Europa Clipper is different. Europa Clipper can detect what's there, can measure ion densities, identify species, track magnetic field draping. That's the term for what happens when solar wind encounters an obstacle. The magnetic field lines drape around the comet like water flowing around a rock in a stream. The pattern is distinctive, recognizable, different from the background solar wind structure. If Europa Clipper flies through 3I Atlas's ion tail, if the timing and trajectory align just right, it will see that draping signature. It will detect ions that shouldn't be there in interplanetary space far from any obvious source. And those ions will tell a story. They'll reveal what 3I Atlas is made of, what's sublimating from its surface, what chemicals are present in concentrations high enough to produce detectable ion populations. This matters because we still don't have definitive composition data. Spectroscopy has given us hints. Carbon dioxide dominates. Water is present but surprisingly low. Nickel compounds appear in unusual ratios. But spectroscopy from Earth-based telescopes is limited. You're looking through atmosphere. You're analyzing light that's traveled hundreds of millions of kilometers. You're working with faint signals and noisy backgrounds. Direct sampling is different. If Europa Clipper's instruments measure ions that came from 3 Atlas, that's in situ data. That's direct detection. That's the gold standard for compositional analysis. You're not inferring what might be there from spectral lines. You're counting actual atoms, measuring actual abundances, getting ground truth. And here's what makes this particularly valuable. Ionails sample different material than dust tails. Dust is the heavy stuff, the particles too large to be ionized efficiently, the rocky grains and organic compounds that reflect sunlight and create the visible tail. But ions are the light elements, the volatiles, the stuff that sublimates easily and gets stripped of electrons by solar radiation. Hydrogen, oxygen, carbon, nitrogen, sulfur, the building blocks of chemistry, the elements that tell you about the object's formation environment. If 3I Atlas formed in a molecular cloud around another star, if it's been drifting through interstellar space for millions or billions of years, its composition should reflect that history. Isotope ratios might be different from solar system values. Elemental abundances might show signatures of different stellar nuclear synthesis. Chemical species might be present that we don't see in our comets. Any of these would be scientifically exciting. Any would tell us something new about planetary formation in other stellar systems. Or alternatively, if certain elements appear in ratios that don't make sense for natural processes, if the chemistry looks engineered rather than naturally evolved, that would be exciting in a completely different way. That would be the kind of data that forces reinterpretation of everything we think we know about the object. The October 30th to November 6th window is narrow. A week. That's how long Europa Clipper spends in the region where 3I Atlas ions might be present. The spacecraft is moving fast, 30 km relative to the Sun, pushing toward Jupiter. It's not stopping. It's not maneuvering to optimize the tail crossing. It just happens to be passing through, and either it detects something or it doesn't. The challenge is sensitivity. Cometry ions are sparse. Even in the central tail, 8 million kilometers from the central axis, they're much more sparse. Detecting them requires instruments operating at peak performance. Requires careful data analysis, requires knowing exactly what you're looking for and how to distinguish it from background noise. Europa Clipper's plasma instrument is good. It's designed to work in the harsh radiation environment around Jupiter to detect tenuous ion populations in the magnetospheres of icy moons. But it's never been tested on cometry ions. It's never been calibrated for this kind of measurement. The team will have to work hard to extract signal from noise to confirm that what they're seeing really came from 3 Atlas and not from some other source. That work takes time. Data gets down, linked from the spacecraft, gets processed, gets analyzed by teams of scientists who compare it to models and predictions, gets peer-reviewed, gets written up in papers. The whole process from detection to publication typically takes months, sometimes years. So even if Europa Clipper detected 3I Atlas ions in early November, we might not hear about it until well into 2026 unless the signal's dramatic, unless it's unambiguous, unless it's weird. Enough that someone decides it warrants immediate attention. Then maybe we get a preliminary announcement. Maybe someone breaks protocol and shares results before full analysis is complete. Maybe the data is too interesting to sit on. But probably not. Probably the process proceeds normally. Data gets collected, analyzed, eventually published, and by the time we read about it in a journal article, 3I Atlas will be long gone out past Jupiter heading back toward interstellar space. The window for follow-up observations closed, the opportunity to gather additional data lost. This is the frustration of studying transient phenomena. You get one shot, one chance to make measurements. If your instruments aren't perfectly tuned, if your timing is slightly off, if conditions aren't quite right, you miss it. And with interstellar visitors, you can't wait for the next one. You can't plan a follow-up mission. By the time we design, build, and launch a probe to intercept an interstellar object, that object is gone. Long gone. So we work with what we have. With the assets already in space, with the missions already flying, with the serendipitous opportunities that orbital mechanics occasionally provides, Europa Clipper wasn't supposed to study 3 Atlas, but it's going to. Whether that study produces useful data depends on factors we can't control. Solar wind conditions during the crossing, instrument performance during those critical days, the actual density and distribution of ions in the tail. We won't know until we know. Until the data comes back, until someone analyzes it and writes it up and shares it with the community. Until then, all we can do is wait and hope that luck favors us, that the trajectory alignment was close enough, that the instruments were sensitive enough, that the tail was dense enough, that all the factors that need to align actually did align. There's something poetic about this. About humanity's most sophisticated mission to study alien life, even if just microbial life beneath ice, accidentally encountering material from an object that might possibly improbably be alien technology. Europa Clipper is searching for biology, looking for chemical signatures of metabolism, hunting for the conditions that might support living systems, and in the process, it flies through the exhaust plume of 3I Atlas. If both things are true, if Europa is habitable and 3I Atlas is artificial, then Europa Clipper connects them, links the search for natural life with the possibility of technological life, draws a line between two completely different approaches to answering the question of whether we're alone. One searching for simple cells in dark oceans, the other stumbling across engineering from another civilization. Most likely neither is true. Europa is probably sterile. 3I Atlas is probably a comet, and Europa Clipper's tail crossing will produce interesting but ultimately mundane compositional data. Carbon dioxide and water and trace organics in roughly the proportions we'd expect. Nothing revolutionary, nothing that changes our understanding. Just another data point in the catalog of interstellar visitor compositions. But there's a chance, a small chance, a probability that's not zero, even if it's not large, that the data from Europa Clipper will surprise us. We'll show chemistry that doesn't fit, will reveal signatures we can't explain with natural processes, will force us to consider possibilities we've been avoiding. And if that happens, if the preliminary results leak before publication, if someone sees something in the data that demands immediate attention, we'll know within weeks. Someone will talk. Someone always talks when the data is truly extraordinary. Someone will share with a colleague who shares with another colleague who posts anonymously online. The scientific community leaks like a sieve when the stakes are high enough. So we watch, we listen, we monitor the channels where information flows, official and unofficial. We wait for the signal that something interesting was detected, or we wait for silence, which likely means nothing unusual was found. Either way, the Europa Clipper Y-ion tail crossing is another test, another opportunity for 3 Atlas to reveal its nature, another chance for us to glimpse what this object really is. The spacecraft flew through in early November. The data is recorded. The truth is already determined, sitting in computer memory somewhere, waiting to be analyzed. We just don't know it yet. Don't know what Europa Clipper saw. Don't know whether the iron tail held secrets or just ordinary commentary chemistry, But we will eventually when someone gets around to analyzing those particular data sets, when someone notices an anomaly or confirms an expectation, when someone decides the results are ready to share. Until then, we're suspended in uncertainty, knowing the measurement was made, but not knowing what it revealed, waiting for information that already exists but hasn't reached us yet. That's the state we're in with 3i Atlas across multiple fronts. Data exists that we don't have access to. Measurements have been made that haven't been shared. Images have been captured that haven't been released. The truth is out there somewhere in databases and file systems and analysts' workstations. But it hasn't reached the public. It hasn't reached the people asking questions. It hasn't reached those of us trying to understand what this object is. The Europa Clipper crossing is just one more piece of that puzzle. One more measurement that might or might not tell us something important. One more opportunity that might or might not pan out. One more thread to pull on in hopes of unraveling the mystery. Juice observation window. November 4th, 2025, SA's Jupiter Icy Moons Explorer passes within 64 million kilometers of 3i Atlas. Not close by astronomical standards, still far enough that you couldn't see much detail even with excellent optics, but close enough to make measurements. Close enough to gather data that Earth-based telescopes can't collect. Close enough to matter. JUICE launched in April 2023. It's been traveling for over 2 years, building velocity through gravitational assists, making its way toward Jupiter, where it will spend years studying Ganymede, Callisto, and Europa. The mission timeline is long. The spacecraft won't reach Jupiter orbit until 2030. Everything about JUICE is patient, methodical, designed for the slow burn of deep space exploration. But on November 4th, JUICE has a brief encounter with something unexpected, something that wasn't in the mission plan when the spacecraft was designed. 3 Atlas didn't exist when JUICE launched, wasn't discovered until July 2025. By the time anyone knew this interstellar visitor was coming through the solar system, JUICE was already en route, its trajectory set, its observation schedule planned years in advance. Yet, someone at ESA looked at the trajectories, did the math, realized that JUICE would pass relatively close to 3i Atlas just days after perihelion, and decided this was an opportunity worth taking, worth adjusting schedules for, worth dedicating spacecraft resources to observe an object that has nothing to do with icy moons around Jupiter. That decision tells you something. It tells you ESA considers 3i Atlas important enough to modify an expensive interplanetary mission, important enough to spend fuel and time and instrument operations on a target that wasn't part of the original plan, important enough to justify the risk, however small, of adding complexity to an already complex mission. Space agencies don't do this lightly. Every maneuver costs propellant. Every instrument activation costs power. Every unplanned observation is time not spent on planned objectives. Mission teams guard their resources carefully. They resist scope creep. They push back against requests to observe targets of opportunity unless the target is genuinely significant, unless the potential scientific return justifies the expenditure. ESA judged that 3 Atlas met that threshold. That tells you how they're thinking about this object internally. Regardless of what they say publicly, regardless of how they frame it in press releases, the operational decisions reveal their assessment. This is worth observing. This deserves resources. This matters. The November 4th observation happens just 6 days after perihelion. 6 days after 3i Atlas made its closest approach to the Sun, 6 days after the optimal window for any hypothetical maneuvers. This timing is crucial. If anything changed during perihelion, if the object performed operations or released components or altered its trajectory, those changes would be becoming apparent by November 4th. Tidal forces from the Sun would be pulling apart anything released at perihelion. Different masses following slightly different trajectories would be separating after 6 days. That separation might be measurable, might show up in imaging as multiple objects where there should be one, might appear in spectroscopy as different emission signatures from different locations. Or if nothing unusual happened, if 3 Atlas behaved exactly like a natural comet through perihelion, Then November 4th observations would confirm that would show one object on a predictable trajectory with activity levels consistent with solar heating would provide the data point that says this is normal. This is explicable. This is not anomalous despite all the speculation. Either outcome is valuable. Either way, Juice's observations help constrain what happened during those hidden days when 3i Atlas was behind the sun. Help narrow the range of possibilities. Help answer questions that can't be addressed from Earth's vantage. But there's a catch, significant one. The data won't be released until February 2026, 3 months after the observation. 3 months of processing, analysis, review, 3 months during which the science team examines what Juice saw, figures out what it means, decides how to present it. Why the delay? Distance. Juice is far from Earth. Communication with the spacecraft takes time. Data downlink rates are slow compared to Earth-orbiting satellites. The Deep Space Network antennas that receive signals from interplanetary spacecraft are shared resources. Time scheduled between multiple missions. Juice gets its allotted windows. Data trickles back, gets queued for processing, waits its turn. This is normal for deep space missions. Nobody expects instant results. The teams are used to working with delayed data with observations that happen weeks or months before they see the actual measurements. Is part of the job, part of the rhythm of interplanetary exploration. But for those of us watching 3 Atlas, for those trying to understand what this object is, 3 months feels like forever. 3 months during which the object continues moving away from the sun. 3 months during which it becomes harder to observe from Earth. 3 months during which whatever happened at perihelion becomes increasingly difficult to verify or refute. By February 2026, 3i Atlas will be well past Earth orbit, heading outward, fading as it increases distance from the sun, still observable with large telescopes, but no longer the bright active object it was during close approach. The window for detailed study will be closing, and we'll only just be getting the Juice data that could tell us what we missed. Unless something forces early release, unless Juice sees something so unusual, so unexpected, so important, that ESA decides they can't wait 3 months to share it. Then, maybe we get a preliminary announcement. Maybe someone at a conference mentions unexpected results. Maybe a press release appears that breaks the normal timeline, but probably not. Probably ESA sticks to their schedule, processes the data properly, lets the science team do their analysis without pressure, publishes results when they're ready, not before. That's how responsible space agencies operate. That's the professional approach, even when everyone desperately wants answers immediately. So, what will Juice see? What instruments are being used for this observation? The spacecraft carries 11 scientific instruments: cameras for optical and infrared imaging, spectrometers for composition analysis, magnetometers and particle detectors for measuring the space environment, radar for subsurface probing, though that's useless for a comet observation. The imaging system is probably the primary instrument for 3 Atlas. Janus, the optical camera, can capture pictures across visible and near-infrared wavelengths. It's designed to photograph icy moon surfaces from orbit, but it works just fine for distant comet observations. The resolution won't be spectacular at 64 million km. You're not going to see surface features, but you can measure brightness, track position, look for extended structures in the coma. The spectrometers are potentially more interesting. MAGIS, the infrared spectrometer, can identify molecular species in the coma, can measure temperature, can detect absorption features that reveal what ices are sublimating. If 3 Atlas has unusual chemistry, if those nickel compounds are present in the concentrations that ground-based spectroscopy suggested, Major should see them, should get better signal, clearer spectra, more definitive identification than Earth-based instruments achieved. The UV spectrograph, UVS, looks at shorter wavelengths, ultraviolet light that gets absorbed by Earth's atmosphere that we can't observe from ground-based telescopes. UV spectroscopy reveals different molecular species, different chemistry, different physics. It's a complementary view that adds information optical spectroscopy misses. Between Janus, MAGIS, and UVS, Juice will build a multi-wavelength portrait of 3 Atlas as it appeared on November 4th. We'll capture data across the spectrum from ultraviolet through visible into infrared. We'll measure composition, temperature, activity levels, spatial distribution of different materials. We'll generate a dataset that Earth-based observations can't match. And that dataset will sit on hard drives for 3 months. We'll wait for downlink windows. We'll queue for processing. We'll slowly make its way through analysis pipelines. We'll eventually emerge as calibrated, validated, publication-ready results in February, long after the observation, long after the moment when the information would have been most valuable. This is the frustration of studying rare events with long distance in spacecraft. You get data, but not when you need it. You get answers, but not when questions are urgent. You get confirmation or reputation of hypothesis, but only after everyone's moved on to arguing about something else. By February 2026, 3 Atlas will be old news. The perihelion passage will be months in the past. The speculation will have peaked and subsided. People will have formed opinions, taken positions, decided what they believe about this object. And then JUICE data arrives, potentially contradicts those positions, potentially forces reassessment, potentially reveals that everyone was wrong about something important, or potentially confirms what everyone already suspected, shows that 3 Atlas is indeed an unusual but natural comet, that all the anomalies have mundane explanations, that the hype was overblown, that we got excited about something that turned out to be ordinary once we had better data. Either way, the JUICE observation is a milestone, a major data point, one of the few close-range measurements we'll get of 3I Atlas during its passage. We should be grateful it's happening at all, grateful that orbital mechanics worked out such that a spacecraft was in position to make these observations, grateful that ESA dedicated resources to capturing them. But gratitude doesn't eliminate impatience, doesn't make the wait easier, doesn't reduce the burning desire to know now, not in 3 months. Doesn't change the fact that information exists, has already been gathered, is sitting in computer memory somewhere, and we can't access it, can't even peek at it, can't get the smallest hint about whether JUICE saw anything interesting. November 4th came and went. JUICE executed its observation sequence, pointed its instruments at 3I Atlas, collected photons, recorded spectra, stored data, moved on with its mission, and somewhere in that stored data is a piece of the truth, a measurement that tells us something important about what 3 Atlas is. We just have to wait to find out what that something is. Wait while the data makes its way across hundreds of millions of kilometers of empty space. Wait while processing pipelines chew through raw numbers and produce calibrated measurements. Wait while analysts examine those measurements and figure out what they mean. Wait while papers get written and reviews get completed and press releases get drafted. 3 months, February 2026. That's when we get answers from JUICE. That's when this particular piece of the puzzle slots into place. Until then, it's another item on the list of things we know exist but can't access. Another tantalizing promise of information to come. Another test of patience for everyone following this story. The spacecraft is functioning normally. The data is safely stored. The downlink will proceed on schedule. Everything is working as designed. The system is doing exactly what it's supposed to do. And that system, efficient and reliable as it is, enforces a 3-month delay between observation and revelation. So, we wait again. Still constantly waiting for the next piece of information, the next data release, the next confirmation or surprise. Waiting is most of what studying 3I Atlas has been. Waiting for observations during visibility windows, waiting for spacecraft to reach observation positions, waiting for data to be processed, waiting for papers to be published, waiting for agencies to decide what they can share. JUICE adds to that waiting list, adds another data point we know is coming but haven't seen yet. Another potential revelation or disappointment, another opportunity for 3I Atlas to surprise us or confirm our expectations. We won't know which until February, won't know whether JUICE saw a comet or something else. Won't know whether November 4th observations support the natural hypothesis or raise new questions. The observation happened. The truth is recorded. We just don't have access to it yet. The 8 anomalies, lobe scale, rank 4. Let's talk about what makes 3I Atlas different. Not speculation, not interpretation, just the measurements, the documented observations, the things that can be checked and verified by anyone with access to the data. 8 specific ways this object deviates from what we'd expect from a random interstellar visitor. 8 anomalies that individually are unlikely but not impossible. 8 data points that together paint a picture complex enough to warrant serious attention. Anomaly 1. Ecliptic alignment. 3I Atlas's trajectory lies within 5 degrees of the ecliptic plane. That's the flat disk where planets orbit, where most solar system objects concentrate, where gravity and angular momentum from the original protoplanetary disk left their mark billions of years ago. Objects born in our solar system tend to orbit near this plane. Makes sense. They formed from material that was already flattened into a disk. But 3 Atlas didn't form here. It came from interstellar space, from some other stellar system where the ecliptic plane would be oriented completely differently. There's no reason for an interstellar object to arrive aligned with our ecliptic. No physical mechanism that would preferentially send objects toward us along that particular orientation. Random arrivals should come from random directions uniformly distributed across the celestial sphere. The probability of random alignment within 5 degrees is about 2%. 2 chances in 1,000. Not impossible, not even incredibly rare, but unusual enough to notice. Unusual enough that if you saw 10 interstellar objects and one was aligned with the ecliptic, you'd wonder why that one. What makes it different? Whether there's a reason it came from that direction. Anomaly 2, the anti-tail. We've discussed this. The sunward-pointing plume that appeared in early observations. The structure that didn't match normal cometary tails. Yes, anti-happen. Yes, they're usually geometric illusions, but this one wasn't. This one was real material, genuinely moving toward the sun against radiation pressure, against solar wind, against the forces that should push everything outward. Multiple telescopes confirmed it. Different viewing angles showed the same structure. It wasn't perspective. It wasn't an artifact. It was actual dust and gas moving in the wrong direction. That requires explanation. Natural explanations exist, as we've seen. Unusual sublimation dynamics, ice fragment behavior, complex interactions between different particle sizes and radiation pressure. But it's still anomalous, still something we haven't seen before in quite this configuration. Anomaly 3, the timing, the arrival schedule that brings 3I Atlas close to multiple planets while keeping it unobservable from Earth during perihelion. Mars approach in October, Venus within range, Jupiter encounter in March, and perihelion occurring during solar conjunction when ground-based telescopes can't see it. The probability of this timing is 0.05%, 5 in 100,000. You could argue this is selection bias. We only notice interstellar objects that come close to planets because those are the ones bright enough to detect. Objects passing through the outer solar system, staying far from major bodies, we'd never see those. They'd be too dim, too fast, gone before we knew they were there. So maybe the timing isn't unusual. We're just sampling the subset of interstellar visitors that happen to approach planets. Fair point, but it doesn't fully explain why perihelion occurs during solar conjunction. That's independent of planetary positions. That's about Earth's location relative to the object in the sun, and having the optimal maneuver window occur when you can't be observed from Earth. That's convenient, suspiciously convenient. Anomaly 4. The chemistry. Nickel to iron ratios that resemble industrial alloys more than natural minerals. Nickel to cyanide ratios orders of magnitude higher than any known comet, including 2I Borisov, our only other well-studied interstellar comet. This is the signature that originally caught attention, the thing that made researchers look twice at spectroscopic data. Iron and nickel usually appear together. They're formed together in stellar nuclear synthesis. They behave similarly in planet formation processes. They condense from the solar nebula at similar temperatures you expect them in. Roughly solar proportions, maybe with some variation depending on formation conditions. But 3I shows lots of nickel, minimal iron. That's backwards. That's not what natural fractionation usually produces. Industrial alloys, however, are different. We make nickel steel. We purify nickel for specific applications. We create materials with whatever ratios serve our engineering needs. If you saw a chunk of satellite debris, or a piece of failed spacecraft, or material from industrial processes, you might see exactly this kind of nickel without iron signature. That doesn't prove 3 Atlas is artificial. but it's another data point that doesn't quite fit natural expectations. Anomaly 5, low water content. Only 4% water by mass in the observed emissions. Most comets are much higher. Water ice is the primary component, the thing that makes comets comet, the volatile that sublimates and carries dust and creates the coma and tail. Comets are often described as dirty snowballs, more ice than rock, more water than anything else. But 3 Atlas is different, mostly carbon dioxide, some water, but not dominant. More like a rock with surface ices than an ice ball with embedded rock. That could be legitimate interstellar diversity. Different formation conditions in another stellar system. Colder molecular cloud, different chemistry. We've only seen 3 interstellar objects. Small sample, maybe low water comets are common out there. Or maybe the bulk composition is rock or metal, and what we're seeing is just surface condensation. Ices that accumulated during millions of years in interstellar space, a coating rather than the main body. Force ablation wouldn't tell us what's underneath, wouldn't reveal whether the interior is ice or something else entirely. Anomaly 6. Extreme negative polarization. Light scattered from 3I Atlas shows polarization properties unprecedented among known comets. Polarization measures how light waves are oriented, whether they vibrate in particular directions or randomly. When light bounces off particles, it gets polarized. The degree and direction of polarization depends on particle size, composition, shape. 3I Atlas produces negative polarization beyond what's been measured for any comet, including 2I Boris. That means the particles in its coma have unusual properties, unusual sizes or compositions or shapes. Something about the dust doesn't match what we see in normal cometary dust. The probability of this particular polarization signature is estimated below 1%. Less than 1 in 100 comets would show this. Again, small sample size. Maybe we just haven't seen enough comets to know the full range of natural variation. Maybe interstellar comets are systematically different from solar system comets. Maybe formation in different stellar environments produces dust with different properties. All possible, all reasonable, but still anomalous. Still something requiring explanation. Anomaly 7, the WOW signal alignment. 3I Atlas's trajectory traced backwards points toward a region of sky within 9 degrees of where the famous WOW signal originated. That radio signal detected on August 15, 1977. 72 seconds of strong, narrow band emission that's never been explained, never been repeated, never been identified with any known astronomical source. The signal came from the direction of Sagittarius, from the general region toward the galactic center, from an area dense with stars. Jerry Ullman, the astronomer who found it in the data, wrote, "Wow!" in the margin because it was so strong, so clear, so exactly what you'd expect from an artificial transmission. And then it vanished, never appeared again, despite decades of follow-up observations. 3 Atlas comes from almost the same direction, 9 degrees away. That's close on astronomical scales. That's near enough that you could imagine a connection. If the WOW signal was a transmission from a probe, if that probe was 3 Atlas, if it announced its arrival and then went silent, the geometry works. The timing doesn't. Not quite. 48 years between signal and arrival. But if the probe was still far out, if it transmitted early as it entered the solar system, maybe the numbers align. This is pure speculation. The WOW signal has numerous proposed explanations, including several natural ones, and 9 degrees is close, but not identical. Not a perfect match. The probability of random alignment within 9 degrees is about 6%. 6 in $1,000. Unlikely, but not extraordinary. Still, it's another piece of the pattern, another thing that makes you wonder. Anomaly. 8. The velocity and trajectory combined. 3E Atlas entered the inner solar system at 44 km/h, faster than 1 Oumuamua, faster than 2I Boris, moving with significant excess velocity relative to local stellar rest frame. That speed combined with the ecliptic alignment combined with the planetary encounter, timing creates a specific arrival configuration with very low probability when you multiply all the factors together. Each individual element is possible. Fast interstellar objects exist, ecliptic alignments happen, planetary encounters occur. But getting all of them together in one object, that's the statistical challenge. That's what pushes the probability low enough to demand explanation. Because while any single weird thing can be chance, 8 weird things starts looking like pattern. This is Lowe's point with his scale. He's not claiming 3i Atlas is artificial. He's claiming it scores high enough on improbability that we should take the artificial hypothesis seriously, should investigate it properly, should gather all the data we can before the object leaves the solar system and the opportunity is lost forever. That's a reasonable position. That's what responsible science looks like when confronted with something unusual. The counter-argument is equally reasonable. 8 anomalies sounds like a lot, but we've only studied 3 interstellar objects in detail, sample size of 3. We have no idea what normal looks like for interstellar populations. We're comparing 3i Atlas to solar system comets. But maybe that comparison is invalid. Maybe interstellar objects are systematically different. Maybe what seems anomalous to us is actually typical out there. Furthermore, we're subject to observation biases. We detect the objects that are big enough, bright enough, close enough to see. We're sampling a tiny fraction of interstellar visitors. The vast majority pass through undetected, so the ones we do see might not be representative, might be selected exactly for having unusual properties that make them detectable. All of this is true. All of it urges caution about over-interpreting limited data. But it doesn't eliminate the fact that 3 Atlas is unusual, doesn't erase the 8 measured anomalies, doesn't change the statistical improbabilities. It just provides context, reminds us that unusual doesn't automatically mean artificial, that we need extraordinary evidence before accepting extraordinary claims. Rank 4 on a 10-point scale. That's where Lowe places 3i Atlas, 4 out of 10, less than half. Not even close to definitive, but high enough to warrant attention. High enough that dismissing it as obviously natural seems premature. High enough that the hypothesis of possible technological origin deserves investigation rather than ridicule. The scale is designed to be objective. Each anomaly gets assigned a probability. Those probabilities get combined. The result is a quantitative score, not a subjective judgment. You can disagree with the specific probability estimates. You can argue that certain anomalies shouldn't count. You can propose different statistical frameworks, but you can't dismiss the exercise as unscientific. It's explicitly scientific. It's attempting to quantify how unusual this object is relative to expectations. And the answer is pretty unusual. Not unprecedented, not impossible to explain naturally, but unusual enough that we should be paying attention. Unusual enough that gathering more data is worthwhile. Unusual enough that when spacecraft have opportunities to observe 3i Atlas, those observations should be prioritized. That's happening. JUICE dedicated resources to observe it. Europa Clipper's trajectory intersects its ion tail. Ground-based campaigns are coordinated across multiple continents. The IAWN training exercise focuses on it. Resources are being allocated. Attention is being paid. The scientific community, despite public statements downplaying artificial hypotheses, is treating 3i Atlas as important. Their actions speak louder than press releases. When missions get retasked, when observation campaigns get organized, when papers get published analyzing every detail that reveals the true assessment, this object matters. These anomalies matter. The 8 data points that pushed it to rank 4 on the Loeb scale matter enough that people are dedicating careers and resources to understanding them. Whether that understanding ultimately confirms the natural explanation or reveals something more extraordinary, we'll find out. The data keeps accumulating. The measurements keep getting refined. The picture keeps coming into focus. And with each new observation, with each additional data point, the probabilities shift. The anomalies either get explained or get reinforced. The score either drops or climbs. Right now, it's 4 out of 10. That's where we stand. That's what the measurements tell us. 8 anomalies, 8 improbabilities, 8 reasons to keep watching this object carefully as it passes through our neighborhood and returns to the darkness between stars. What comes next? December through March. The story isn't over. 3 Atlas hasn't left, hasn't finished whatever it came here to do. Whether that's natural gravitational passage or something more deliberate, the coming months will tell us things the past months couldn't. We'll provide data that's currently impossible to gather. We'll test predictions and resolve ambiguities and potentially force us to completely recalibrate our understanding of what this object is. December 19th. Mark that date. That's when 3I Atlas makes its closest approach to Earth, not close by any reasonable definition. 269 million kilometers farther than the Sun, farther than Mars at its nearest, but closer than it's been, closer than it will be again as it heads back toward interstellar space, and close enough that Earth-based telescopes will have their best view of the post-perihelion object. This is the critical observation window, the moment when amateur astronomers can contribute meaningfully. When backyard telescopes, when citizen science networks, when independent observers around the world can point their instruments at the same target and gather data that doesn't flow through official channels, that can't be filtered or managed or delayed by institutional review processes. If anything unusual happened at perihelion, if 3 Atlas released objects, or changed trajectory or activated systems, December will reveal it. The object will be visible, well-positioned in the sky, bright enough for modernized telescopes to capture detailed images. And thousands of observers will be watching, comparing position measurements, looking for anything that doesn't match predictions, searching for evidence of activity that natural comets don't exhibit. This is when the whistleblower's prediction gets tested. Remember the claim in December: many home-based observers will see it all. If that statement has any truth to it, if there's genuine insider knowledge behind it, December is when we find out when the object emerges from the blind spot and reveals what happened during those hidden weeks. The prediction is specific enough to be falsifiable. If December arrives and 3I Atlas looks exactly like a normal comet, if nothing unusual appears, if independent observations match gravitational predictions perfectly, then the whistleblower was wrong or lying or misinformed, and we can dismiss that particular thread of speculation. But if something does appear, if observers start reporting anomalies, if position measurements show trajectory deviations, if multiple independent sources document the same unusual features, then we have a problem. Then the speculation becomes evidence. Then the possibility that was dismissed as conspiracy theory becomes something that demands serious investigation. The window extends beyond December. 3 Atlas will remain observable through the winter months for Northern Hemisphere observers, gradually fading as distance increases, gradually becoming harder to track, but still accessible to serious amateur equipment and certainly to professional observatories. The observation campaign continues. The data accumulation doesn't stop. And then March 16, 2026, Jupiter flyby. 3 Atlas passes within 54 million kilometers of the solar system's largest planet. Close enough that NASA's Juno spacecraft can observe it. Close enough that Jupiter's gravity might perturb the trajectory in measurable ways. Close enough that if there are active systems on the object, if there's anything drawing power or generating emissions, Juno's instruments should detect it. Juno carries sensors designed to study Jupiter's magnetosphere, to measure radiation belts, to detect charged particles and electromagnetic fields. These instruments are sensitive, sophisticated, capable of detecting subtle signals against noisy backgrounds. If 3 Atlas is emitting anything at all in radio or ultraviolet or particle radiation, Juno is positioned to see it. The infrared instruments are particularly interesting. Juno's JERHAM, the Jovian Infrared Auroral Mapper, can measure thermal emission, can detect heat signatures, can identify temperature distributions that reveal where energy is being generated or radiated. If there's something inside 3I Atlas producing heat, if there are active systems running, if the object's thermal properties don't match what you'd expect from a passive ice and rock body, Durham should notice. This observation has been officially recommended. Avi pushed for it. Congresswoman Anna Paulina Luna wrote to NASA requesting it. The scientific justification is clear. Jupiter encounter is the last opportunity for spacecraft observation before 3I Atlas exits the inner solar system. After March, it heads outward, crosses the outer planet orbits, fades into the deep space background, becomes impossible to study in detail. So, March is it. The final exam, the last chance to gather close-range data with instruments that can measure things Earth-based telescopes can't detect. The last opportunity to confirm or refute the hypotheses that have accumulated around this object. After March, we're done. We analyze what we have. We draw conclusions from incomplete data. We accept that some questions will never be answered because we missed the window. Unless Juno sees something extraordinary, something that demands follow-up, something that justifies scrambling resources for additional observations even after the object should have faded from priority lists. That's unlikely. Space missions have schedules, budgets, competing priorities. Once 3 Atlas is past Jupiter, it's past interesting. It's old news. Resources will shift to newer targets. Attention will move on. But between December and March, we have time. We have opportunities. We have multiple observational windows with different assets bringing different capabilities to bear. Each observation constrains possibilities. Each measurement narrows the range of viable explanations. Each data point helps resolve the ambiguities that currently make 3 Atlas so frustrating to interpret. The trajectory question gets answered during this period. By comparing December observations to predictions, by tracking position with precision, by measuring any deviations from pure gravitational motion, we'll know whether 3I Atlas maneuvered. The measurement is straightforward. The interpretation might be complex, but the data is clean. Either the object is where gravity says it should be, or it's not. There's no ambiguity in position measurements if it is where it should be. If the trajectory matches predictions within measurement uncertainty, that's strong evidence against the artificial hypothesis. Natural objects follow gravitational paths. They don't deviate. They don't make course corrections. Finding 3I Atlas exactly on its predicted track would suggest nothing unusual happened at perihelion, would support the natural comet explanation, would lower its rank on the Loeb scale significantly. If it's not where it should be, if there's a measurable discrepancy, that's a different story. Then you have to explain the deviation. Solar radiation pressure affects trajectories, but the effect is calculable. Outgassing creates rocket effects that can perturb orbits, but those effects correlate with activity levels and should match observations of coma brightness. Any deviation that can't be explained by known forces is a problem, is evidence that something else influenced the object's motion. That something else could still be natural. Could be outgassing from a vent we didn't observe. Could be rotation-induced jets that pulsed at the wrong time for us to measure them. Could be density variations in the solar wind creating unexpected drag. Natural explanations exist for almost anything. But some natural explanations are more plausible than others. Some require fewer assumptions. Some fit the broader pattern of observations better. If 3 Atlas shows trajectory deviation that requires significant force to explain forcing consistent with observed activity levels, that's when natural explanations start getting stretched, start requiring multiple unlikely things to happen simultaneously, start looking less probable than alternatives. We've been avoiding the IWN campaign runs through this entire period. November 27th through January 27th, coordinated observation from multiple sites, standardized measurements, shared data protocols. This is planetary defense infrastructure operating at full capacity. Every telescope in the network pointed at the same target, every observation logged and cataloged and made available for analysis. On paper, it's a training exercise, a way to test systems and procedures, a rehearsal for what would happen if a genuine threat appeared. But it's also an unprecedented observational campaign. The most intensive coordinated study of an interstellar object ever undertaken. Resources on a scale that wouldn't be justified for pure scientific curiosity. Resources that make sense if you're genuinely concerned about the object. If you think there's a real possibility it's something other than what it appears. The campaign generates data, lots of data, position measurements accurate to fractions of an arcsec. Photometry tracking brightness variations, spectroscopy monitoring composition changes, all of it time-stamped, all of it georeferenced, all of it feeding into databases that multiple teams can access and analyze. This is what modern collaborative science looks like. This is how you study something properly when it matters enough to dedicate resources. and the results will be published eventually after analysis, after review, after institutional processes grind through their stages. By late 2026, papers will appear, conference presentations will happen, results will trickle into the public sphere. We'll learn what the campaign found, whether the intensive observations revealed anything unexpected, whether the training exercise uncovered anything that justifies the effort that went into it. But we won't wait until then to have opinions. We won't suspend judgment until official results appear. Because the amateur community will be watching too, posting images, sharing measurements, discussing anomalies. The internet doesn't wait for peer review. Social media doesn't respect institutional timelines. If something interesting appears, if backyard telescopes capture evidence of unusual activity, that information spreads immediately. This is both good and bad. Good because it prevents information control. Bad because it enables misinformation. Good because it democratizes access to data. Bad because it makes verification difficult. Good because it forces transparency. Bad because it rewards sensationalism over accuracy. The distributed observation network is powerful but chaotic. It produces signal and noise in equal measure. Separating them requires time and expertise that most people don't have. So we'll get a confused picture. Multiple narratives, competing interpretations. Some observers will see anomalies everywhere. Some will see nothing unusual anywhere. Most will see ambiguous data that supports whatever they already believed. And through all of that noise, slowly, gradually, a consensus will emerge. Not because anyone proved anything definitively, but because enough independent observations will accumulate that patterns become apparent, that outlier claims get isolated, that the most reasonable interpretation becomes clear even if it's not certain. This is how science works in practice. Not clean experimental designs with controlled variables, but messy opportunistic observations of natural phenomena that don't cooperate with our desire for clarity. We gather what data we can. We analyze it as carefully as possible. We try to be honest about uncertainty, and eventually, we reach conclusions that are probably right even if we can't prove they're right. 3I Atlas will be studied this way through the chaos of December observations and the discipline of IWN campaign and the technical sophistication of Juno instruments, through amateur enthusiasm and professional rigor, through speculation and measurement, through hope and skepticism, and somehow, out of all that mess, we'll figure out what this object is, or at least what it probably is, or at minimum, what it probably isn't. The timeline is set, the observation windows are known, the assets are positioned, everything is ready. We're just waiting for December to arrive, waiting for 3I Atlas to emerge from behind the sun and show us what it looks like after perihelion, waiting to see whether anything changed, whether any surprises await, whether the hidden weeks produced anything worth hiding. The answer exists already. Whatever happened at perihelion happened. The object's current state is determined, its trajectory is set, the evidence is there, moving through space, carrying the truth with it. We just haven't looked yet, haven't pointed our telescopes in the right direction with sufficient precision to see what's real and what's speculation. But we will soon. December is coming. The observation windows are opening. The data will flow. The questions will start getting answers. Not all the answers, not perfect clarity, but enough to move forward. Enough to shift probabilities, enough to know whether 3I Atlas is extraordinary or whether we made it extraordinary through hope and imagination and the desperate human desire to not be alone in the universe. The information warfare playbook. There's a pattern here, a recognizable structure to how information moves or doesn't move around 3 Atlas. If you've watched enough government responses to unusual events, if you've studied how institutions manage public knowledge when the stakes are high, you start recognizing the playbook, the specific moves, the predictable sequences, the tells that reveal when something is being actively managed rather than passively reported. 3 Atlas exhibits the pattern. Not perfectly, not with the coordination you'd see in a genuine conspiracy, but enough that it's worth mapping, worth understanding, worth recognizing so you can see through it when it happens. Stage 1. Discovery and initial assessment. An object appears, gets detected by automated surveys, gets flagged as unusual. The data flows into databases, researchers access it, initial analysis begins. This stage is open, transparent. The discovery gets announced through proper channels. The Minor Planet Center publishes the orbital elements. Other observatories confirm the detection. Nothing is hidden because nothing sensitive has been found yet. It's just another space rock until someone looks closer. 3 Atlas pass through this stage normally. July 1st discovery announcement. Follow-up observations confirming interstellar origin. Early papers noting unusual brightness and activity. All public, all accessible, all flowing through the standard channels that serve the astronomical community well. No red flags, no delays, no signs of information control. Stage 2, anomaly recognition. Someone notices things don't quite fit. The spectroscopy is weird. The trajectory is suspicious. The timing is too convenient. Now, information flow gets more interesting. Some researchers start being careful about what they publish. Some observations get delayed while teams verify unusual results. Some data gets shared privately before being released publicly. Nothing nefarious, just scientists being cautious about making claims they might have to retract. But institutions start paying attention. Space agencies start monitoring the situation. Committees start having meetings about potential scenarios and appropriate responses. This is where the control mechanisms activate. Not because there's proof of anything unusual, but because there's enough ambiguity that someone needs to be thinking about what happens if this turns out to be significant. What happens if the unusual features are real? What happens if public attention escalates beyond what normal scientific channels can handle? 3 Atlas hit this stage in late July and August. Papers started appearing with careful language. Observed anomalies described but not interpreted as necessarily artificial. Lowe began publishing his analysis. Other researchers began pushing back. The scientific debate started happening in public and private simultaneously. Data was still flowing. Observations were still shared. But you could see the caution creeping in, the awareness that this object was generating attention beyond normal astronomical interest. Stage 3, containment and review. This is where information control becomes active, not suppression, not cover-up. Just making sure everything flows through proper channels, making sure nothing inflammatory gets released without institutional approval, making sure that when information does go public, it's been vetted, contextualized, framed appropriately. The government shutdown provided perfect cover for this stage. NASA can't release data because they're furrowed. China doesn't release images because their analysis isn't complete. ESA releases limited observations that don't reveal much. Everyone has legitimate reasons for delays. Everyone has procedural justifications for why certain data isn't available yet. Nothing looks suspicious because everything has a mundane explanation, but the effect is the same as if it were coordinated. High Risisk images remain unreleased. Spectroscopic details are sparse. Activity reports are vague. The most detailed observations, the measurements that could resolve key questions, those are stuck in the pipeline, somewhere being processed, being reviewed, being prepared for eventual publication. Just not yet. Not while the object is still in the news, not while people are actively watching and wondering. This is information warfare through bureaucracy, through the normal functioning of institutional processes that can be slowed when convenient and accelerated when desired. No one gives an order to delay release. That would be obvious, documentable. Someone would leak it. Instead, the review processes just happen to take longer than usual. The data queues just happen to get backed up. The publication pipeline just happens to have bottlenecks, all explainable, all defensible, all producing the same result as active suppression without any of the risks. Stage 4, narrative establishment. Once enough time has passed, once initial speculation has peaked and started to fade, official information begins flowing. Papers get published, press releases appear, data gets released. But now the narrative is established, the interpretation is set, the framing is in place. When the hairy images finally appear, they'll come with expert analysis, with context, with explanation of what you're seeing and why it's consistent with natural processes. The data will be real. The images will be authentic. But they'll arrive embedded in an interpretive framework that guides how people understand them. This isn't lying. This isn't manipulation in the crude sense. It's communication strategy. It's responsible science communication. You don't just dump raw data on the public and let them draw whatever conclusions they want. You provide context. You explain what the measurements mean. You guide interpretation so people don't jump to unwarranted conclusions. That's what responsible institutions do. That's what science communication is supposed to be. But it also means the institutions control the story, control which details get emphasized, control what questions get addressed first, control which interpretations seem most reasonable to non-expert audiences, and that control, even when exercised with good intentions, shapes public understanding in ways that might not align with what the data actually shows. Third, Atlas hasn't fully reached this stage yet. We're still in containment and review, still waiting for official data releases, still operating on limited information and lots of speculation. But when stage 4 arrives, when the papers start appearing and the press releases flow and the data becomes accessible, watch how it's presented. Watch what gets emphasized. Watch which anomalies get explained and which get downplayed. Watch whose interpretation becomes the standard view that everyone repeats. Stage 5, the slow fade. Once the narrative is established, once the official interpretation is set, attention gradually shifts elsewhere. New stories emerge, new astronomical discoveries get announced, resources move to different priorities. 3 Atlas becomes old news, a topic for specialists, no longer front-page material. The general public moves on, stops asking questions, stops demanding answers, accepts whatever conclusion was established during stage 4. This stage is already beginning. You can see it in coverage patterns. 3 Atlas was everywhere in July and August, every science outlet covering it, every space enthusiast watching updates. But by October, the coverage had declined. Fewer stories, fewer updates, less public attention. Not because the object became less interesting, but because the news cycle moved on. Because human attention is finite, because stories have life cycles, and this one has peaked. By the time we get definitive data, by the time JUICE results appear in February or Juno observations get analyzed in April, most people will have forgotten they were waiting for answers. Most will have formed their opinions and moved on. The data will be published. The papers will appear, but they'll be read by specialists, not by the millions who watched breathlessly in July when every new image sparked speculation. This is natural. This is how news works. This is the rhythm of public attention in the information age. Nothing sinister about it, just the reality that people can't maintain focus on any single story indefinitely. Other things happen, other mysteries emerge, other questions demand attention, and gradually, imperceptibly, yesterday's burning question becomes today's forgotten topic. But here's what makes the playbook insidious. If you wanted to hide something, if you wanted to prevent public understanding of something genuinely unusual, you wouldn't suppress it. Obviously, you wouldn't classify everything and refuse to comment. That creates backlash. That generates conspiracy theories. That makes people suspicious. Instead, you'd let the information flow, but slowly through proper channels with appropriate review, with responsible framing. You'd let the news cycle do its work. Let attention fade naturally. Let the story age until most people stop caring. And then, when the definitive data finally appears, it lands in a context where nobody's watching anymore. But the handful of specialists who read it can't generate enough noise to reignite public interest. Maybe that's what's happening with 3 Atlas. Maybe the delays are strategic. Maybe the data is being held until attention fades. Maybe by the time we get answers, most people will have decided what they believe and won't care enough to revise those beliefs based on new evidence. Or maybe the delays are exactly what they appear to be. Normal bureaucratic processes, normal scientific caution, normal institutional functioning that just happens to be slow, because that's how institutions work. No strategy, no coordination, no playbook, just the accumulated friction of multiple organizations with different priorities and procedures trying to do their jobs properly. The truth is probably somewhere in between. Some delays are strategic, some are genuinely procedural. Some data is being held for review. Some is stuck in normal publication pipelines. Some information is being managed carefully. Some is just moving slowly through bureaucratic channels. Distinguishing which is nearly impossible from the outside. You can see the effects, you can note the patterns, but you can't determine intent without inside knowledge. And that's the beauty of the playbook. It works whether or not it's intentional, whether or not anyone's actively implementing it. Because the natural functioning of institutional information management looks exactly like coordinated control. The bureaucratic delays look exactly like strategic holds. The normal review processes look exactly like censorship. You can't tell the difference without documentary evidence of intent. And that evidence, if it exists, is exactly what would be most carefully controlled. So where does that leave us? Watching information patterns, noting discrepancies, observing which data flows and which doesn't. Recognizing the structure even if we can't prove coordination, understanding that the absence of information is itself informative. The delays tell stories, that what's not said often matters more than what is said. The playbook exists. We can see its effects in how information about 3i Atlas has moved over these past months. Whether anyone's consciously executing it, whether it's emergent rather than designed, that's unknowable. But the pattern is there, clear enough to recognize, consistent enough to map. And recognizing it helps you understand why certain data hasn't appeared yet, why certain observations remain unpublished, why the story that seemed so urgent in July has gradually faded from headlines, even though the object is more interesting now than it was then. The information warfare playbook explains these patterns, makes them predictable, shows you what to expect in coming months as Stage 4 unfolds and Stage 5 takes over. We're being managed, our expectations are being shaped, our understanding is being guided not through lies or suppression, but through the timing and framing of information release, through the natural functioning of institutions that understand communication strategy, through processes that work the same way whether they're consciously coordinated or just emergently structured. And maybe that's appropriate. Maybe the public does need guidance. Maybe raw data without context leads to more confusion than clarity. Maybe responsible institutions should control narratives around potentially sensitive topics. Maybe information warfare is just good communication under a more honest name. Or maybe we deserve unfiltered access to data. Maybe we're capable of drawing our own conclusions. Maybe institutional control, even well-intentioned, is patronizing at best and dangerous at worst. That's a values question, a political question, one that people will answer differently based on their prior about trust and authority and the role of institutions in democratic societies. But regardless of whether you think the playbook is appropriate, it exists. It's being executed. It's shaping what you know and when you know it and how you interpret it. And understanding that, seeing the structure, recognizing the pattern that gives you power, power to question, power to look for information in places is not being offered. Power to recognize when you're being managed and to resist that management if you choose. The story of 3i Atlas is still being written. The final chapters haven't happened yet, but the information infrastructure around that story, the systems that determine what becomes known and when and how, those are fully operational. They were activated months ago. They're running smoothly, doing exactly what they were designed to do. And whether that's protecting us from premature conclusions or preventing us from reaching correct ones, we'll only know in retrospect after it's too late to matter.